Hi. So in order to avoid, the incident that happened last time where I was speaking and I didn't know that I was no longer recording, I'm going to use both my laptop and my iPad to give lecture today. That way I can see you guys and see the chat available while also going over our lecture today. Sound good?
Sounds good.
Awesome. All right, so let's go ahead and go with today's notes. So we're continuing with 7.3. So my plan for today is to go over some notes for today, a new section, also work on your review. You have an exam coming up, and that way we can go ahead and, I don't know, just be more prepared for it, I guess. I remember I had an instructor.
Professor?
One more time?
The review is it going to be due on test day, you said?
I haven't said that, but yes, it will be due.
Oh, okay. I wasn't sure. Okay.
I will go ahead and make it for extra credits before, and I'll go ahead and go over it with you question by question. I know this is something that one of my favorite professors would do, is he would give you a review, he would have a review day, and he would just do every single problem from the review, even though he emailed you the review with all the work in it. But I don't know, it was just something I enjoyed.
I feel like this is gonna be really helpful because for the last pre-test, we didn't really do it together and I kind of struggled with some questions.
Okay, yeah. And we'll do this and then you can let me know what you like best. But you already said this would be good, so that's good to hear. But I also don't want to fall behind because we only have 3 more weeks of class. 3 more weeks, I believe, right? We're in week 14. So we have this week, next week, and 1 more week. So we have 3 whole weeks left.
Do you have
When is our final?
Going to work?
All right, so you have 2 finals. You have a final May 28th, and that's your core rec final, because that counts as a separate class. And then your next final is, it's scheduled for June 9th, but I'm gonna make it available the whole finals week, so you can choose when you want to take it. I know some of you are taking other classes, so you get to choose whether it's something you just want to knock out early or wait till the end. I don't know what your workload is, what you would like to do, but it's going to be available from the 8th up until the 11th. That's my plan.
Okay, and is it going to be due like the same like day of, like one day, or are we gonna have like an open for the first one?
One more time, what was that question?
For the first final, the one on May 28th, is that going to be open on one day and due same day? Or
oh, no, it's going to be open several days. Yeah, okay. Yeah, I understand what you said now. It's going to be open several days. So it's due the 28th, but I'm going to do it multiple choice. So I don't have to have that extra amount of time to grade, because it takes a lot of grade. So my plan is to make it available from next week, May 26th. It's going to be a Tuesday, and have it open up until Saturday. So 5:30.
Is it going to be, are both finals going to be like one large portion, or are they going to be split like the last 2 tests into 2 sections?
Your 136 final is going to be just one multiple choice.
Okay.
I think I can get away with that. Okay. But for your final, I know I'm going to have to include an open response portion for sure.
Okay. So that's going to be, the final is going to be probably split into 2 sections like we've been doing, kind of. Okay, no worries.
Yeah.
Wanted to know ahead of time.
Yeah.
Are we, if we do any graphing, are we going to have to like use our own graphing paper, or just like get it as close as possible?
It would have to be like before. You can either print out grid that I make available to you, or you can use your own paper and pencil to make a grid.
All right, just curious.
Yeah.
Thank you.
Alrighty. Let's go ahead and continue with our new section 7.3. All right. let me go ahead and share my screen. All right. So let's go ahead and start with our lecture for today. So do you guys get an echo?
Yes, ma'am.
Yeah, I wonder why we have an echo.
I see two Angela Bakaris.
You're on this probably on
that's
the
why?
meeting.
Well, I know there's two because I have one on my screen and I have one here, but I'm muted. What if I'm muted? There's no volume.
I'm not hearing the
It's
echo
better
anymore.
now. It's not there
Okay.
anymore.
I wonder what happened. Okay. All right, so let me go ahead and share my screen. We're going over 7.3.
All right.
Catherine wrote, there's a bit of an echo. The echo's gone. Thanks, Catherine. All right, so I'll have the chat open so you can go ahead and reach out to me. But so far, you guys just get the textbook, right? 7.3. All right, so let's go ahead and go over this section. Cool, thanks. Let's go over this section pretty quickly, just because I want to spend time with a review, but I also don't want to spend too much of your time with me because I know it can be draining to be on Zoom for so long. All right, so 7.3, solving right triangles. So before we begin, recall that all angles of a triangle add up to 180, right? Oh man, that goes there. Let me.
Can you force mute everybody?
I can. That's probably what it is, right? Good catch. Participants, mute all. All right, so again, if you have any questions, just unmute yourself, but when you're done with the question, can you please mute yourself back? Because it's probably gonna go from your own desk. Thanks. All right. So we know the sum of a triangle is 180s, yeah. And we like to reserve the upper cases for our angle measures, right? And we like to reserve the lower cases for our sides. All right, so we're gonna be working with triangles that aren't always 90 degrees. So we know how to deal with them when we have Pythagorean theorem. But what about when it's not? What can we do to solve our triangle to find all the sides? Well, we can use trigonometry like we have in the past. Let's go ahead and jump to example 3. In example 3, we're given the measure of 2 sides, and the Pythagorean theorem is used to first find the measure of the third side. So example 3 reads, in triangle ABC, A is equal to 10 feet and C is equal to 13 feet. So let's write that down. Lowercase a, we have 10 feet. Lowercase c, I have 13. Find the missing values, round to the nearest tenth. So that's 1 decimal place. Okay, so we know we have 90 degrees, and that's special because that lets us use Pythagorean theorem and work with our rules that we applied so far with trigonometry. All right, so if I know 2 sides and it's a right triangle, I can rely on our Pythagorean theorem. So that's what we're doing here in A. We can use the Pythagorean theorem to find our missing side. Our last missing side is B. Okay, so we use our formula A squared plus B squared equals C squared. Remember that C is always the largest side. And that larger side is always the side that corresponds to your 90 degrees. So here we have our 90 degrees, therefore it's that side. Now your book is really nice and it reserves the C for your longer side when you're working with Pythagorean theorem, but it's a good note to just keep that in mind because not all books would be that nice. All right, so we have that our C is our hypotenuse. All right, so we have our A is 10 and our C is 13. We have to find B, which is a leg. So it goes there. Okay, we do some algebra. We're left with B squared equals 69. You take the square root of both sides, not a pretty number. The cool thing now is we're introducing calculators, right? So we can just punch this in our calculator, square root of 69, we get 8.3066. It wants us to round to nearest tenth, which is 1 decimal place. So our answer is about 8.3. So we can write that down. We get 8.3 for B. Okay, now we need to find these angle measurements. Before, we used to rely on that. The sum was 180, we have 90 degrees, and we were given another angle. So then we just had to subtract. Here, it's not going to be as easy, but we have some tools that we can rely on. We have our trig functions. All right, so I want to find a side. I want to find an angle measurement, but I'm going to work with an angle measurement I know. Recall your 3 trig functions. We have that sine is equal to opposite over hypotenuse. Cosine, well, you need an argument, right? So let's write x. Cosine of x is adjacent over hypotenuse, and tangent of x is opposite over adjacent. Okay, well, the cool thing is if we like our triangle, we have an angle measurement, right? Because I know that little box is supposed to represent 90 degrees. So if I want to find a side, I just need to pick that side and work with our hypotenuse. Now, which one works with hypotenuse? You have several options, right? You have sine, that works with hypotenuse. You have cosine, that works with hypotenuse. It's just a matter of labeling your sides. So let's go ahead and do what your book gave you. So sine of A. So notice how your argument is A. That's super important because that's your your perspective. That's where you're going to look at. So let's go ahead and mark A. So A is our sign here. You can label it X or theta, whatever you'd like. That's A. Okay, sine of your argument is opposite over hypotenuse. So opposite of A, we have little a, which is 10. Let me get rid of that. Opposite of A is 10. So we have that here. And then the fraction is sine of x is equal to opposite over hypotenuse. We have our opposite, now we need our hypotenuse. Our hypotenuse measurement is 13. So we write a fraction of 10 over 13. So sine of A is 10 over 13. Now our only unknown is A. That's the only thing we don't know. We don't know what that is. Can we figure out what that is? Yeah, we did that in 7.2, where we're using our calculator to find that theta, your argument. It's not always theta, it could be x or angle measurement. So let's go ahead and write 10 over 13 as a decimal. You can go ahead and type it into your calculator. You don't have to write it down on paper, you can just have it saved on your calculator. Now, how do you get A by itself and undo that sign? So we see here, we have sign here. In order to get rid of that sign, I have to go ahead and do sine inverse. So I'm going to type in sine inverse of 0.7692. Go ahead and punch into your calculator. So every calculator is different. You look at sine, you want sine with a little -1, your inverse, and it's usually your second command or your shift command. So I type in sine of 0.7692. 692, and we get it's 50.28210381. It's a long number. And so we round to nearest decimal place, first decimal place. So I want that decimal place to look at the one after it to round. If it's between 0 and 4, you keep your place. If it's 5 to 9, you go up one. So here we want to round to the first decimal place. So look at the number after it. 8 is between 5 and 9, so I go up. So I round to 5.3. That'll be my answer for A. Now your question is saying to find all of the missing values. And we see here that we don't just have one missing value, we have one more side to go. We have to find that side measurement, that angle measurement of B. Okay, well, we can go ahead and repeat this process, do sine or cosine with that view of angle B, or you can subtract from here. You know the triangle is 180. You know one side is 50.3. So you can go ahead and subtract from 180. You can do 180 minus our right angle minus 50.3, and you'll get 39.7. Or you can just use this idea that if one of them's 90, you only have 90 degrees left to work with. Subtract what you know. That same idea, but for some reason, subtracting 180, while taking 180 and subtracting what you know, just comes more intuitive to me. All right, so here's a problem. We just did an example. Go ahead and give this a try. I know it's lengthy and I know it's pretty new, so I'll give you more time than usual. I'll give you 5 minutes. And if you have any questions, you can go ahead and just voice your question, or you can post in the group chat and I'll try to get back to you. So I'll give you 5 minutes. So 2:33, that's when I'll stop you.
I do have a quick question.
Yeah.
Is there a reason why we should convert it to a decimal rather than just going with the fraction?
Your calculator, when it gives you the degrees back, it's going to give you a decimal. Now in your work, you don't have to force the decimal, but your answer will be a decimal.
Right,
so
correct,
like
yeah.
here, you don't have to change the 10/13 to a decimal. You can just keep it as 10/13 your calculator.
Got it. Okay.
Yeah. Alrighty. So I'm going to go ahead and work this out with you guys. If you're not done, that's okay. Continue to work. If you're done, you can just follow along and see if you're on the right track. All right. So our question says, in triangle ABC, C is equal to 4.7 centimeters. B is equal to 3.9 centimeters. Find the missing values, round each to the nearest tenth. So that's 1 decimal place. Find lowercase a. Okay, so that's what we want to find first. Because we have a right triangle, and we know that because we have that little box where that C is, right? Because we have a right triangle, it allows us to use the Pythagorean theorem. So we know we can use a squared plus b squared is equal to c squared. Okay, well, let's go ahead and fill this out. So we know C is our hypotenuse, so our letters match up to our rule. That's good. A is our unknown, so we'll leave that as a squared plus b. B is 3.9 squared is equal to c, which is 4.7 squared. All right, so I have a squared is equal to, well, I guess maybe I should write it in squares. Well, I don't want a square, it's gonna be big. So I have a squared plus 3.9 squared is 15.21. And 4.7 squared is 22.09. We want to get a squared, so we subtract 15.21 minus 15.21. We get that a squared is equal to 22.09 minus 15.21, 6.88. All right, we want a, not a squared, so we take the square root, plus or minus. But because it's a side measurement, you can't measure something and get a negative measurement, right? That doesn't make sense. So it's by default plus. So we get that a is equal to the square root of that number. We get 2.622975541. No objections? Should we go around to 1 decimal place? No, okay. So we get 2.6 for A. All right. That was A. Let's go ahead and do B, which is find angle A, uppercase A. All right, I want to find this measurement. Let's label it theta. I want to find that unknown. Okay, well, I know some of my side measurements, right? I know C and I know B, which comes from your hypotenuse and your adjacent side. So let's go ahead and work with that. Let's do cosine side. Well, it doesn't matter because we have our whole triangle solved, right? Didn't we find that A is 2.6? So we have our whole triangle side worked out. So we can use whatever we want. Let's go ahead and use something with our hypotenuse. So I guess sine is a preferred one. I'll use cosine for B. Sine is equal to opposite over hypotenuse. All right, so I have sine of theta. My opposite measurement, my opposite side is 4.7. And your hypotenuse, I'm sorry, I got carried away. I lied. Ignore everything I said 3 seconds ago. All right. So we want opposite and hypotenuse. Opposite would be 2.6, and your hypotenuse is 4.7. Now, every opposite would be different depending on your angle, but because we're looking at this is where our eyes are. That does not look like an eye. It looks like a roach. That's where your eye is. That's where your eye is looking. So from this perspective, that's your opposite and that's your hypotenuse. All right, so opposite we have 2.6 and hypotenuse we have 4.7. All right, we want to find theta. We need to undo the sign. So we do sine inverse so that we have theta is equal to sine inverse of 2.6 over 4.7. And like your classmate said, you don't have to change it to a decimal before you punch into your calculator. If you do, that's okay too. All right, so we have theta is equal to, let's punch this in, sine inverse of 2.6 divided by 4.7, close your parentheses. You get 33.58623919. Now our instructions clearly say to round to the nearest tenth, so one decimal place. So we have theta is equal to 33.6. All right, let's go ahead and take a look at B. I want to find uppercase B, so that means angle B. All right, so we did sine. Let's go ahead and do cosine just for a change. Just do something different. Let me pick a different color. All right, I want to find now my angle B, right? This is what I'm looking at. That's my eyesight for now. I'm going to erase my markings in blue just so I can guide you with this problem and erase my roach looking eye. All right, so this theta, this angle B is my eyesight. That's what we're looking for. Now, for a change of, just to keep it different, we want to have, we did sine, let's go ahead and do cosine. So cosine of theta is defined as adjacent over your hypotenuse. Okay, from here, what's adjacent? What's next to it? We have these two sides next to it, right? But one of them is hypotenuse. So that one's already special. So we don't count that one. So therefore, it leaves 2.6 as our adjacent side. All right, so let's go ahead and do that. Now, yeah, it's a similar fraction, but we're working with cosine, which has a different effect. All right, so I have cosine of theta is equal to adjacent, which is 2.6 over hypotenuse, which is 4.7. We want theta by itself, so we undo that cosine. So I have theta is equal to cosine inverse of 2.6 over 4.7. Let's go ahead and work that out. Use your calculator. All right, so I have theta is equal to 56.41376081. If I round to one decimal place, it'd be 56.4. Now, I just did it to show a different setup, but we already had one angle, right? We had that A was 33.6. So to find B, an alternative, which would have been much less work, is we could have just taken 180 minus 90 for our right triangle. I'm sorry, for our right angle, and then minus 33.6. And we should get the same answer. So 180 minus 90 minus 33.6. Cool. I'm not crazy. Yeah. So we have that B is equal to 56.4. But I just wanted to show you different ways. It doesn't matter what you're using, as long as you label your sides appropriately, it'll work out. So we see here how our fraction, let me point this out, our fractions look the same, right? We have 2.6 over 4.7, but we have a different command. One of them has sine, one of them has cosine. So you're gonna get a different answer. As long as you're working with your side measurements properly, it works out. Now, a good way to avoid making a silly mistake is you can go ahead and write cosine is adjacent over hypotenuse, or sine is opposite over hypotenuse. That keeps you from making a silly mistake because we all make them. I make them all the time. All right, so this is how we can use what we've known so far to find more, solve a triangle. Now I have a comment that says 2.5. For A, did someone get 2.5? Is that what that's asking? Oh, okay.
For A, I got 2.6 and 33.92.
Okay, so it's good?
Yeah.
Okay. All right, so make sure you're punching things correctly. Every calculator is different. If you're getting different commands, or different answers, let me know, and I'll see how your calculator works. I can't say always do this or that because every calculator is different. All right, let's go ahead and do example 4. So we can work with more involved problems, but we can still use all the techniques that we've known or have learned thus far. All right, so let's go ahead and do example 4. If a diagram involves, let me get rid of the right. If a diagram involves more than one triangle, it is often helpful to separate the diagram into 2 or more triangles and look for relationships. When separating a diagram, correct labeling is very important. Sometimes an extra label, such as H below, is helpful in setting up relationships between variables. Example 4. In the diagram at right, the measurement of angle BAC is 31 degrees and has it marked BAC is 31, okay? And then it says that measurement of BDC is 65 degrees and the distance from A to D is 90 meters. Find the distance from C to D labeled in the diagram. Separate the figure into 2 right triangles, BAC and BDC. Use tangent to set up 2 relationships between H and X and find a way to eliminate H. The resulting equation should have X as only one variable. So we have 2 triangles and it's saying we know some parts. So to remind you, tangent is made up of opposite over adjacent. All right, so we have your opposite side and your adjacent side. And looking at this angle, this would be the opposite, and that would be the adjacent. Well, we want to work with some pieces together so that we can find our unknowns. Now we're using the idea that these 2 triangles have some sort of relationship, right? So we're using a setup for each one. In triangle 1, this is triangle number 1. We have that tangent to 65 is H over X. So opposite is H, adjacent is X. And in triangle 2, we have a similar setup where tangent of 31, our opposite, we don't know what that is. So let's label that H. And our adjacent side, well, that's the side that have in common, right? So our adjacent side is made up of I'm sorry, I said that wrong. So H has that same side. Triangle 2 is the whole triangle. So our opposite side, they share the opposite side of H. And your adjacent side would be 90 plus X. All right, well, we have that similar side. this is what we want to have. We have that same side of h. So what we can do is I can set one of them equal to h, get h by itself, and then replace it with your h on your other equation. So that way we only have one unknown, which is x, which is what you want to find. All right, so what we do here is we go ahead and we solve for h. All right, so that means we want to multiply that 90 plus x on both sides. Now we have h isolated. So then, because h is equal to h, right? Why don't we bring one of them here? So we isolate for h as well. Multiply x to both sides. X times tangent of 65. And then we already solved for h on the other side. So we have 90 plus x times tangent of 31. And now we're left to only solve for one variable. Okay. From here, we can multiply tangent of 31 to both sides. So we're left with 90 times tangent of 31 plus x times tangent of 31 is equal to x times tangent of 65. Now we want to get x's on the same side because we want to solve for x. So let's get them all on the same side of the equation. So let's go ahead and subtract x tangent of 31. All right, our x's are on the same side. Why did we put them on the same side? Because we want to isolate, we want to factor out the x. All right, so let's factor the x. Now we can get x by itself by dividing out what doesn't have that x. And then from there becomes calculator work. So you can punch into our calculator to get that x is equal to 35 meters. This is different, but it's a good way to use your algebra skills along with what we know about our triangles to work this out. Let's go ahead and do another one. This is an in-class example, so I'll do this with you guys. All right, so in this diagram at right, the measurement of angle ABC is 70. All right, and measurement of angle ADC is 51. Find the distance from A to C. We'll label A to C. Oh, and the distance from A to C is 110. Find X, the distance from C to D, which is X. And Y, the distance from C to B. And the distance from B to D. Well, let's both put them together. All right, so let's go ahead and see what we have in common. So let's go ahead and redraw our triangles. So we have triangle, that's C. I'm looking at this triangle. That would be C, A, and D with that right angle. And from A to C, it's 110. And D is 51. That's what we have. Let's draw the other triangle that shares at 90 degrees. That 90 degrees also C, and then we have A and B. C is 90, from A to C is 110, and B is 70. Let's label this triangle 1, and let's label this triangle 2. And that's an A, not a triangle. All right, so we want to see what they have in common. Now, every triangle setup will be different. This one was given way different than the one that we had before. So the one we had before, they all kind of have that same side together, right? Now we have another triangle, but if we redraw it, we see that they have the same side, right? They have this side right here. Let me highlight it. We have this perspective and this side right there. So let's go ahead and proceed the same way. So what do we have? We have an opposite, and we're trying to find our x and our y. Let's label them. Our x is between that D and that C. And our y is between that C and that B. So we want to find x and y. So what trig function can I work with where I work with, if blue, that highlighted side in blue is what we want, I want to work with my opposite side and with my adjacent side. Okay, in this case, I will also have to work with tangent. So let's set up an argument for each triangle. So I have triangle 1. For triangle 1, we're working with opposite and adjacent. Let's use tangent. If you feel risky and want to use cotangent, you'll get the same answer. All right, so I have tangent of theta. Or actually, it's not theta. We have a measurement, right? Isn't it 51?
Yeah, I mean, DC, yeah.
51. And tangent is opposite over adjacent. So I have 110 over adjacent, which is x. All right, and I have triangle 2. And that would give me tangent of 70. And that would give me opposite over adjacent. Opposite would be 110, and adjacent would be my y. Okay, this one's different. It's different because in the other one, it was set up so that we had the same variable, x, h, and we can just work it out, right? But here, we have different variables. We have an x and a y. So what would be the best choice? I'm stuck here. If I solve for x, then I can't rewrite it. But what if I solve for 110? Then I'll be two variables. Let me try. So if let's solve for 110, so that's what they have in common. If I do, then I have to multiply x to both sides, and I'm left with x times tangent of 51 is equal to 110. If I solve for 10, then I have to multiply by y. By y. And so I'm left with y of tangent of 70 is equal to 110. And we set up the same argument, 110 is equal to 110. Then I can have x tangent of 51 is equal to y tangent of 70. And that doesn't really help us. We still have two unknowns. I'll get back to you on this problem. It's not too sure what we're supposed to do.
All right.
I'll get back to you. Okay, so your homework for this section will be problems. Problems 1 through 6 all.
1 through 6 all? All right.
Okay, let's go ahead and look at your review. Let's do a couple of problems and then we'll go ahead and jump out and take a break because I don't want to keep you on for too long. So let's take a look at your review. Give me a second, let me go ahead and change review there. All right. There we go. It appeared. Okay, so let's take a look at your test 3. Now, before we begin, I want to let you know that there's some problems that we won't do because we didn't do one of the sections for chapter 6, not chapter 5. We didn't do half angle formulas. So you can skip problems. Oh, it doesn't have any here. Okay. Never mind. Okay, so let's go ahead and work some of them out. So let's go ahead and do number 1 to begin with. Now, number 1 reads, for each item in column 1, give the letter of the item in column 2 that's equivalent to it. Okay, so I have to work these out and I have to find some way where I can write into a more condensed form, such as what we have on our right. Okay, so let's go ahead and start with A. I don't know what to do, right? At least that's how I always feel in the beginning of these type of problems. Whenever you think, okay, I don't know what to do next, why don't you try changing it to sine and cosine? So as I'm working through this, I, for one, have my unit circle out, right? And I have my formulas sheet out so that when I get to them, I have it ready. All right, cosecant is the inverse of cosine. So cosecant will be not cosine sine, 1 over sine theta. And secant is the inverse of cosine, so 1 over cosine theta. All right, this is just one big division problem, right? So let me rewrite it. I have 1 over sine theta divided by 1 over cosine theta. All right, let's multiply. So I have 1 over sine theta times cosine theta over 1. So that I get cosine theta over sine theta. Does cosine theta over sine theta give us something? Yeah, that's cotangent. Tangent is sine over cosine, cotangent is cosine over sine. So this is cotangent theta. Is there one that's cotangent theta? That's I, right? So this one would be I. Any questions on 1A?
No, that was pretty straightforward.
Okay, cool. Let's take a look at B, secant, tangent, and cosecant. Again, I don't really know what to do here. Let me try changing it into terms of sine, cosine. All right, so secant would be 1 over cosine. Tangent, remember, we only want sine and cosine, so this would be sine over cosine. And cosecant That'd be 1 over sine theta, right? And they're all being multiplied. So let's go ahead and multiply them out. If I multiply it, I'm left with 1 times sine times 1. I have sine theta over cosine. There's 2 cosines, cosine squared times sine theta. All right, I see I have a sine over sine. And that gives me, that's away. So I'm left with 1 over cosine theta. You go check on my dogs. I hear a lot of noises. So does one match that or a way, a similar version of that? Poaching. Do I have one that's 1 cosine theta? No, right? Maybe I have to write it so that it's not 1 over. So I can write it to be cosine would be secant theta. Do I have a secant theta?
Yeah.
Oh, the square. So this would
Squared.
be a secant squared, right? So that would be A. Okay, let's take a look at this next one, C. Any questions about B?
No, not that.
Nope. All right. So again, I'm not too sure what's going on here. Let's rewrite it. So I want to write everything in terms of sine and cosine. So sine is itself, so nothing different there. Cotangent, well, I know tangent is sine over cosine, so cotangent would be the opposite. So it'd be cosine over sine. And then I have plus cosine, that's already in cosine over sine. If I put over 1, I see that my sines divide out, right? So we're left with just cosine theta plus cosine theta. Okay, when we're adding and multiplying, they're very different. If you're ever like unsure, think of them as x's. What is x plus x? 2x, right? So cosine theta plus cosine theta would be 2 cosine theta. It wouldn't be cosine squared. It would be if they're being multiplied, but they're being added. So different effect. Do I have a 2 cosine theta? That would be E. All right. Next one. I have 2 tangent theta divided by secant squared theta. All right, let's change this in terms of sine and cosine only. So I have 2 times sine theta over cosine. And secant squared, well, secant is 1 over cosine. So that would be 1 over cosine squared. Okay, let's rewrite this. I know it looks weird. Complex fractions always look more scary than they actually are. Rewrite it. If I rewrite it using division horizontally, we have 2 sine theta over cosine theta divided by 1 over cosine squared theta. And usually once we get here, students are like, okay, we know what to do. To divide, we keep change to multiplication and flip the second. So I have 2 cosine theta, sine theta over cosine theta times, you flip that one, cosine squared theta over 1. All right, I see that my cosines can cancel, so that's gone, and that's no longer square, it's just 1. So then I'm left with 2 sine theta times cosine theta. And there's nothing else I can do. It's already in terms of sine and cosine, so I have to, if something matches that. And if it doesn't, then I have to go back to the drawing board, right? So do I have a 2 sine theta cosine theta? Darn, I don't. I don't have that. Well, I see it. I see that there's some double angles there, right? Does this kind of look like a double angle? I'm not too sure. Let me check. So you go ahead. You take out your sheet with your double angles, right? And you're like, do I have one with a 2 cosine sine deal? And you do, right? We have that 2 sine A cosine A is 2 sine A. So this is 2 or sine 2A. 2A, but instead of A, we're using theta, so we'll say theta. And they're like, okay, that matches C. So sometimes they'll look exactly what it is, but we take a look at our options, we can kind of wiggle our way through it. So this would be C. Okay, that one was different. Any questions on 1D? No? Alrighty. So let's go ahead and look at E. Well, before we change into sine and cosine, let's first multiply it out. So I have to FOIL. Do you notice that this is a special kind of FOIL? Right? This is differences of squares because we have the same number, but they're conjugates. So we know our answer should be secant squared minus 1. Squared theta minus 1. That's our answer. And if you didn't catch that, that's okay. Let's go ahead and multiply. So secant times secant gives us secant squared theta. Secant times 1 plus secant theta. -1 times secant minus 1 secant theta. And -1 times 1 minus 1. All right, we see that our secant subtract to make 0. So that we're left with secant squared theta minus 1. All right, let's go ahead and take a look at our answers. And we see that none of them match, right? I don't have a secant squared theta minus 1. That's a bummer, but we're pretty confident about our work. So maybe we should write it with a Pythagorean identity. Secant squared, that one matches up with which one? Tangent, right? So we know this would be the same as tangent squared theta. And we see we have a tangent squared theta there. Cool. So E is B. All right, last one, F. I have secant minus tangent theta times sine. I'm not too sure what's going on there. Let's go ahead and change that secant and tangent in terms of sine and cosine. So secant would be 1 over cosine theta minus sine theta over cosine times sine theta. Okay. So we see we have sine times sine, so that's gonna give me sine squared. I have 1 over cosine theta minus sine squared theta over cosine theta. Now we want to subtract. And for that to happen, they need to have a common denominator. Do they have a common denominator? Yeah, they do. So we keep that cosine of theta as a denominator, and I have 1 minus sine squared theta. Whenever you see a square, you want to take a look at your identities. You have double angle identities and you have Pythagorean identities that have a square. So 1 minus sine squared, that would give us cosine squared. Cosine squared theta over cosine squared theta. Oh, not squared, just cosine. All right, we can divide a cosine out, so that's gone, and that's no longer square. So we're left with cosine theta. All that work just to get cosine theta. Do we have a cosine theta? And we do, that would be D. All right, so there's your work for the first problem A. It's a lot of work. You're gonna have some problems like this. Again, there'll be a mixture of multiple choice and open response. We've been here for about an hour. Let's go ahead and take a 5-minute break. Not too long because I don't want to take up your time, but not too short where you can run to the kitchen and get something to drink or a snack.
Sounds good. I'll be back at 18.
3:18? Okay. We're back. So how was your break? What did you do in your break?
I'm back.
You're back.
Me too.
Anyone go do anything fun? Go play with your pet.
I got some chips.
Got some chips. I was thinking of getting chips, and I thought, man, then I'm gonna be thirsty. No
That's
chips
not
for me.
my favorite drink. I'm all about the LaCroix. I like the seltzer waters.
Really?
Yeah, I'm a
Man,
sucker.
I can't get into them. I know they're so cool, and I see people drinking. I'm like, oh, I want to be cool like them. But no.
They just help me cut the soda habit. It's honestly, it's the easiest way for me to just not like. I find myself just grabbing one of those and I'm like, instead of a soda.
Oh man, no, I'm addicted to Coke. Like we have a mini fridge only for the Cokes.
Dude, that's my wife. I do my best to like, hey, try these. They're really good. And she's like, yeah, they're okay. And then it's back to the Coke.
Uh-huh.
Uh,
Especially like whenever I remember when I'm in Mexico, like everyone in Mexico is a big Coke drinker.
Oh,
So
yeah,
for
you
breakfast, it's Coke.
Coke. It's like tacos always come with the side of Coke over there.
Yeah, everything's Coke over there. It's awesome. Love it. Catherine says her dog's too old to play with. Oh, my dogs are really old to play with too. Eating chips. I was supposed to go feed my cats, but I didn't. So I told my husband to feed my cats. Okay, so let's take a look at 2. 2 is a chunk of questions. And these chunks of questions, they're really depressing the grade because they're not the point makers in a test for sure. Okay, so I want you to take a minute. So I sent you a sheet that looks like this. I don't have one printed out, but it's from the book. And it has all of your trig functions. And if you don't have this with me, you also have it on your Bob Pryor website. Not that one exactly, but a sheet that looks like just all of them printed out. It says trig identities and formulas. Why don't we go to it now? So if you have some of it printed, maybe side by side, you can go ahead and take a look. That's not what I wanted. Okay, you can click my name, and is my screen showing? No, right?
No, I'm not saying. I see you now.
Oh, only your name
Okay.
shows.
Only my name shows. Thanks.
Oh, there we go.
There we go. Okay.
I still can't see it. Never mind. I can see it now.
It gave me a countdown before you can see it. Okay. So I went to your Bob Pryor website and I clicked my name. And you have in your pretest and answers, I believe. Is that where it is? No. It's somewhere along that link because everything is there. It's just if you click on the top, it gives you like a shortcut. So if you just scroll, after you click my name, so let me take you back. So you just click my name, and amongst all that stuff, you also have resources. So this is why I stole that graph template, but you also have your identities worksheet. So I'm gonna click that first one, trig identities and worksheets, and you have everything. You have your basic trig identities, you have your Pythagorean identities, and you also have the new ones. These are the new ones, right? We have those double angle formulas and your sum and difference formulas. So I don't know if you want to take a screenshot of this. If you don't have it handy, take a screenshot. If you have a Mac, it's Command 3. If you have a Windows, I don't know, I think it's Command Windows button print or something like that to take a screenshot. So you just have that image. That way you can minimize it and have it handy as we work through the problems. So if you look at these, they kind of look like what we have in our review. So I'm going to jump back to your review. So if you look at your review, this is what 2 kind of looks like, right? So let's take a look at that first one. For our first one, we have cosine, cosine, minus sine, sine, sine. So what kind of fits that formatting? Cosine, cosine, and a minus sign. This would be your sum and difference formulas, but which one? All right, we see, cosine what?
A plus B.
A plus B, right? So we have cosine of A plus B is equal to, and it looks like this, right? It's cosine of A, cosine of B minus sine of A, sine of B. So this is what this is, right? Pardon all my scribbles. But that's how you identify. You think, what kind of fits this pattern? And a minus and a plus is really important to keep track of because they all kind of, for sure for me, they all kind of just blend into this mess that is these types of problems. All right, so I have cosine, cosine, and I have a minus I'm going to add. So if we let this be A, if we let this be A and we let this be B, I can rewrite it, right? Because there's no cosine of 35. So if you take a look at your unit circle, there's no 35 cosine, right? So how would we find that value? Well, if we use our formula right here, I can take cosine of A, which is 35, plus cosine of B, which is 115, and I can go ahead and add them. Maybe that will give me a number that's within my unit circle. And we get 150. Is 150 a measurement in a unit circle? Yeah, that's something you can work with. So I still have a unit circle handy. So we look at unit circle, 150 is right here, and cosine is always your first number. So it's negative square root of 3 over 2. And that's our answer, negative square root of 3 over 2. Do we see how 2a happened? Any questions? So when you see this problem on your exam, you'll be fine? Okay,
Yeah.
I'll take your silence as a yes. Okay, so let's go ahead and take a look at 2b. I'm going to zoom in a lot because I don't want you to kind of see the rest of the problems. All right, so I have 1 minus 2 sine squared 3 pi over 8. I don't know what that looks like. I know if it's sine cosine plus sine cosine or sine sine cosine cosine, it's like those sum ones. But what does that look like? So let's take a look at our problems. So our problem is 1 minus 2 sine squared. So 1 minus 2 sine squared. It kind of looks like, oh, I can write on it, but it looks like one of those double angle formulas. It looks like that fourth one, cosine 2a, from your double angle formulas. Right? So your formula, your formula is cosine of 2a is 1 minus 2 sine squared of a. That's our formula from the book. And we see it kind of matches the skeleton. 1 minus 2 sine squared, and we can let a be that. So let's go ahead and take this part, work with that, and let's say let a equal 3 pi over 8. Okay, so that I have cosine of 2 times a, and we said a is 3 pi over 8. Okay, the problem here is that there's no 3 pi over 8, but multiplying it by 2, that will make things work out, right? So here we can divide by 2, we can cross cancel, so now we get 4. So I have cosine of 3 pi over 4. That's a value in our unit circle, right? So we go ahead, take a look at unit circle, and we find 3 pi over 4. 3 pi over 4 is right here in that second quadrant, and cosine is the first number. So our answer is negative square root of 2 over 2. So our answer is negative square root of 2 over 2. That is 2B. Any questions about this one? I know when we first saw double angle formulas, there was something that had a lot of questions. Does it make more sense now?
Yeah.
Yeah, okay. All right, jumping into C. All right, I'm trying to kind of make it so we don't get confused with what's above. So I have cosine of 5 pi over 12, sine of pi over 12 minus sine of 5 pi over 12 times cosine of pi over 12. So I see sine and cosine being multiplied with a minus in between. So what's a mixture of sine and cosine with a minus in between? So I'm looking at my formulas. Which one does it kind of look like? And if I want sine and cosine together, I see cosine, cosine, that's not it. Sine times cosine, I see sine times cosine with a minus, right? And this would be, let me write it down. Sine of A minus B is equal to sine of A times cosine of B minus cosine of A times sine of B. All right, things look good. I have a mixture of cosines and sines, but that multiplication, that order is not the order that I want, right? But because these numbers are being multiplied, order doesn't matter in multiplication. So I can swap the order, right? So I can rewrite it. I can take the time to rewrite it as sine. I want sine first. So sine of pi over 12, cosine of 5 pi over 12, minus, I want sine first. So that'd be, I want cosine first, I'm sorry. Cosine would be cosine of pi over 12 times sine of 5 pi over 12. Okay. We did it. We just took the time to rewrite it a bit. All right, so this will let me know if I ran out of space. So if we let A be pi over 12, and we let B be 5 pi over 12, I can rewrite it with sine of A minus B, right? So I can do sine of pi over 12 minus 5 pi over 12. All right, work it out. And that gives us negative 4 pi over 12. And that can be reduced to negative pi over 3. All right, negative is not a big deal, it's just direction. So positive pi over 3 would be that third tick mark, right? I know it's not helpful because my screen is probably super tiny. Pi over 3 is that third tick mark. But because we want negative, we're going to go the other direction. That would give us that negative pi over 3. And if I want sine, that's that negative number. So our answer would be negative square root of 3 over 2. Okay, I'm going to rewrite 2D since I ran out of space above to be sine of 105 times cosine of 105. Okay, moving forward, let's take a look at 2D. So looking at 2D, it's not one of those sum and difference. So let's take a look. What can it maybe be? Let's take a look at our identities. I have a sine times a cosine, right? Sine of 105 times cosine 105. Is there a problem where I only have sine and cosine? There is, right? That first double angle formula. If we take a look at that first double angle formula, I have a sine of A times cosine of A. But in my problem, I don't have a 2. So that's that problem. So by your formula, we have two, let me write the whole formula. Sine of 2A is equal to 2 sine of A times cosine of A, right? And I see I have sine and cosine, but that 2 is a big problem. I'm missing that 2. So why don't I rewrite it with the 2? But that 2 isn't there, so I'm going to erase it. That 2 is missing, right? But we want that 2. We can write that 2. But I also need to write a 1/2. Because if I multiply them, that's just 1. And 1 doesn't change anything. So we're not changing the value of our problem. But now I can go ahead and just focus on this. I can focus on this right here because that matches my formula. 2 sine of A times cosine of A. All right, now 105 is not a value in my unit circle. So let's go ahead and use what it's equal to. So sine of 2 times A, if A is 105, it would be 2 times 105. All right, sine of 2 times 105 is 210. All right, let's find sine in a unit circle at 210. At 210, sine is negative 1/2. That's what that's equal to. But that 1/2 did not go anywhere. So I still have to multiply it by a negative 1/2. We multiply, so we get positive 1/4. Wait, that 1/2 was never negative. That first one right here, right? This is not negative. I don't know why I wrote negative. So erase that. So therefore it's a negative times a positive times a negative, we get a negative 1/4. Okay, let's go ahead and take a look at 3. I think I'll stop after 5. That way I don't keep you guys for too long. We'll stop at 4. Let's see how far we get at 4. All right, so let's try to hurry so we can do as many problems as we can. So let's go ahead and do 3A. We're given that secant theta is 5 pi over 5, not 5 pi, 5 over 3, and theta is between 270 and 360. Evaluate the following. All right, so So we have to see what we want. So I know by my formula, I want to find cosine of 2 theta, and cosine of 2 theta, or 2a, whatever you want to call it, you have 3 options for that one. Pick one of them. So I'll pick cosine theta minus sine theta, minus sine squared theta. That's cosine of 2a. Now here it's telling me a hint about our problem. Let me try to ignore the other part of my chicken scratch. It's telling me some stuff. It's telling me that secant theta is 5/3. And we're in quadrant 270, between 270 and 360, that's quadrant 4, right? 360, 270, we're working somewhere here. That's our triangle. And secant is 5/3. Now, I usually don't remember our inverses, our reciprocals, but I know cosine is x over r, so therefore secant theta is r over x. So this is one of those weird problems where you have to find y, x, and r, or x, y, and r. So you find x, y, and r. We're told by secant that my r is 3, my r is 5, and my x is 3. That's given from secant theta. Now we have to find y. Well, let's use our triangle to see what each one is. So x is 3, my r is 5, so I need to find y, right? That's my y. I use Pythagorean theorem. So we use x squared plus y squared equals r squared. So we have 3 squared plus y squared is equal to 5 squared. 9 plus y squared equals 25. Y squared we subtract, we get 16. Y is equal, take the square root, you get 4. So y is equal to 4. So now we have to find sine and cosine. Cosine is found by x over r, and sine is found by y over r. All right, cosine is x, which is 3, over r, which is 5. And sine is y, which is 4, and r, which is 5. So now I can fill out this formula here. Cosine squared theta minus sine squared theta. All right. So to continue, cosine squared would be 3 over 5 squared minus sine squared, which is 4 over 5 squared. And there we go, we just work it out. So we have 9 over 25 minus 16 over 25. So our answer is 7? -7? And that's our problem for that one. That's our answer for that one. I'll skip 3B because I have a lot of work written there. And I don't want to make it more messy than what it already is. So we'll do 3B next time on Thursday. All right. Let's go on to 4A. So I want to prove the identity. I want to prove that this is equal to 1. So again, if you catch it enough, if you've seen it enough, and you catch it by seeing it enough. If you don't see it more, if you don't see it, if you don't practice it, or have done problems like your homework with this, you might not catch it as easily. But if we're doing your homework, you might have noticed that this is a difference of squares. Notice that we have the same numbers, but they're conjugates, right? So our answer once we multiply is going to be a squared minus b squared.
Professor?
Yeah.
The other one says cotangent.
Oh man, I did not catch that. All right, let's go ahead and multiply. Now we have to multiply. All right, so I want to prove my daddy. When you're working on the days you have to prove, you want to pick the hardest looking side because that's something you can work with. So let's go ahead and work with our left-hand side. So let's multiply. 1 times 1 is 1. 1 times cotangent squared is cotangent squared. Negative cosine squared times 1 is minus cosine squared theta. And cosine squared times cotangent squared gives us negative cosine squared times cotangent squared theta. All right. So I see here that there isn't much we can do. We have a cotangent squared and cosine squared, and then I have cosine squared theta times a cotangent squared theta. Forgot my theta. Well, maybe I can rewrite some of it as a identity. Or maybe even better yet, can't I rewrite it as a trig identity before multiplying this mess? So isn't this a Pythagorean identity? Isn't this a Pythagorean identity? Yeah, right. So you take a look at your Pythagorean identities, and 1 minus cosine, what is that? 1 minus cosine, you get sine squared. And then 1 plus cotangent is cosecant squared. Right. So this looks a lot better. I should have caught that earlier on. We have those squares, think Pythagorean identities. All right, this is what we have. And now we see that these two that are being multiplied, they're inverses of one another, right? If you'd like to rewrite it in terms of sine and cosine, that's sine squared theta times 1 over sine squared theta. So then they divide to make 1. So our answer is 1. And then we can say 1 is equal to 1. And you have proved your identity. Well, that wasn't so bad. I totally was freaking out for a minute. All right, moving forward, let's take a look at 4B. All right, so for 4B, it's kind of a bit of work. So let's go ahead and start by changing it in terms of sine and cosine. Maybe that'll be helpful. All right, I'll start up here so I have enough space. So cotangent would be sine over cosine, so it'd be cosine over sine, cosine theta over sine theta, times tangent, which is sine over cosine, minus, that's already cosine, so let's leave it as cosine, cosine squared, all over cosine theta times tangent, which is sine over cosine. All right, as I was writing this, we already see a lot of things that can be divided out. So cosine and cosine, sine and sine, they're gone. And here, my denominator, my cosine divide to make 1 too. So what do we have left over? We have 1 minus cosine squared theta all over sine theta. Okay, our goal, our final answer is to be able to get sine. All right. Well, almost there. We see a square, so we should be thinking Pythagorean identity. 1 minus cosine squared will give us sine squared. So we have sine squared theta over sine theta, which gives us sine theta, which is our answer. So we have sine theta is equal to sine theta. So that's 4B. All right. So let's take a look at 4C. So I have secant theta over secant squared theta minus 1 is equal to cotangent theta times cosecant theta. All right, so I want to work with the harder looking side. So maybe the left-hand side is a bit more complicated looking. So as I'm looking through this, I want it to equal the other side. And on this side, there's no squares, right? There's no something squared. So maybe I want to undo it. So let's start off by taking that and rewriting it so I don't have that minus anymore. So let's take a look at our Pythagorean identities. And secant squared minus 1 would be tangent squared. So I have secant theta over tangent squared theta. All right. I want cotangent times cosecant. No square. Well, let's try to write it in terms of sine and cosine. Maybe that will help. So secant would be 1 over cosine theta divided by tangent would be sine over cosine. So sine squared theta over cosine squared theta. Let's rewrite it. So I have 1 cosine theta divided by sine squared theta over cosine squared theta. That's 1 over cosine theta times, we flip it, cosine squared theta over sine squared theta. All right, we're there. So if we're looking at this, you can see some things divide out, right? My cosine cancels, that's no longer square. And we're left with, well, that's all gone, that's 1 times cosine, just 1 cosine over sine squared theta. All right, that's still not what we want. I want a cotangent and I want a cosecant. Well, I know cotangent is cosine over sine and cosecant is 1 over sine. So why don't we split it? So I have cosine theta over sine theta times sine theta, right? Because it's a square. And why don't we group it differently? Why don't I group this one as 1 to get my cotangent theta? And then what I have left over is 1 over sine theta. All right, I can rewrite 1 over sine theta to be cosecant. So I have cotangent theta times cosecant theta. There we go. And that's what it's supposed to equal. Okay, let's continue with 4D. 4D. I have sine theta over 1 minus cosine theta is equal to cosecant theta plus cotangent theta. All right, so pick the side that looks easiest to hardest to you. Always start with the more complex looking side. And I think the left-hand side is the one that's uglier looking, right? All right. So let's see, what can we do? Well, I'm thinking we multiply by the conjugate so that we can get that denominator out of the way, right? So if I want to get the denominator out of the way, maybe we can try multiplying by the conjugate, which is 1 plus cosine theta, 1 plus cosine theta, so that we have 1 plus cosine theta times sine theta all over, and our denominator will have 1 minus cosine squared theta after we multiply. And that will help us get rid of that denominator. Hopefully, that's the deal. That's the plan. All right, so 1 minus cosine, that's a Pythagorean identity. That would give us sine squared. So we now have a sine squared theta. And above, we have the same. We can actually distribute it if you like, so that you have sine theta plus cosine theta times sine theta. Or not, let's not multiply it out. The reason why I'm going against it now is because I'm looking at it and we can hopefully cancel out a sign. So I have 1 plus cosine theta times sine theta. All right, before we move forward, can we clean it up a bit? And we see now, yeah, we can clean it up a bit. I have a sine that can cancel out from the bottom, so that's no longer a square. And if we do so, we now have 1 plus cosine theta over just the sine theta. And I think I think you got it. Now I'm going to do that silly thing I always do. This sine is dividing the 1, and it's also dividing that cosine. So I can split it. 1 over sine theta plus cosine theta over sine theta. And now we can clean it up a bit. 1 over sine theta, that gives us cosecant theta, plus cosine over sine, that gives us cotangent theta. And that matches our right-hand side. Okay, we have 3 more minutes, and I think we can do 5 before we leave. All right, let's take a look at 5. So it's getting us ready for solving equations, our chapter 6 work. So 5 reads, find all radiant solutions for x. Okay, so I want to find what value gives you -2 for secant. Okay, well, it wants all of them. So I know I have to write that plus 2 pi k, where k is contained in E, or in Z. But I first need to find that base. What base gives us a -2? All right, let's set ourselves up. I always draw the all students take calculus, and I want to know where secant is negative, right? So secant is negative, secant is the opposite of cosine. It'll be negative right there in quadrants 2 and quadrants 4. All right. Now, secant. We take a look at unit circle, and we see that secant is 2 at 60 degrees. All right, so I take a look at my 60-degree mark, my theta hat of 60, and that leaves me with 120 degrees. and 240 degrees, right? From these two quadrants, because that would give me a -2. But we want radians. So we want x is equal to 120 is 2 pi over 3, and 240 is 4 pi over 3. That's our answer. Now we have to write it a special way. This special way is as two different answers. So x is equal as, we write a curly bracket. In math, curly bracket means a set or a collection of something. In this case, it's a collection of answers. So we write a curly bracket for our answer. So x is equal to 2 pi over 3 plus 2 pi k. And our other answer is 4 pi over 3 plus 2 pi k. You have to say that k is within the integers, within z. And that's our answer. The part we need to find was this, but still do not forget, because it's very important to write plus 2 pi k. That's part of our answer as well. So again, when we're working with all these problems, always have your unit circle handy. I always have it handy. I mean, I do it often enough, but I still use it because I want to be able to not make a silly mistake. Let's go over to this problem 5b. Cotangent of x is square root of 3. All right, so it's positive. It's positive, so I'm going to draw my little alternate state calculus. I'm going to keep track of where it's positive. First quadrant, they're all positive. Cotangent is the inverse of tangent. So quadrants 1 and 3, those are the ones we want. All right, cotangent, so we look at a unit circle, our little chart. You have all of them, so you don't have to do as much thinking if you don't want to. Cotangent is square root of 3 at 30 degrees. So we're looking at the theta hats that all have 30 degrees, which are those small angles. So I would have 30 degrees and also 210 degrees. That's what I'm looking at. But we don't want degrees, we want radians. So we look at our unit circle and we look at the radian that matches that. So 30 degrees is pi over 6, and 210 degrees is 7 pi over 6. So it wants all of our answers. So we have x is equal to pi over 6 plus 2 pi k, and 7 pi over 6 plus 2 pi k, when k is contained in your integers. So it's the same because we want all of the answers, we want an infinite amount of trips around the unit circle. So the way you write that in math is by writing that 2 pi, so that same position over again, k. So k would be 1 loop around, that'd be 1. 2 loops around would be a k of 2. 3 loops around would be a k of 3. Or you can also go negative direction too. That'd be a negative k. So that z means that k can be positive, negative, or 0. All right, so we got up to number 5. I think that's pretty good. All right, I'll stop here because I don't want to give you Zoom gloom, as I once read it's called. But we'll continue on Thursday. And maybe on Thursday we won't cover anything new. Maybe, I don't know. I think we'll just review on Thursday. That way you can take your exam from Thursday on. I want to make sure you have the complete review done. All right. Are there any questions before we wrap up our lecture for today?
I have one.
Yeah.
So for the radians is plus 2 pi k, and then the degrees is 3 plus 360. I don't remember the rest.
K.
360 what?
It is a k.
Oh, 360 k. Okay.
Mm-hmm. So instead of 2 pi, write 360. Same deal.
Okay, thank you.
You're welcome. Good question. And that would be number 7, but it's a bit more work. No, number 6. You can do number 6 without me. It's pretty much the same deal, the same type of problem, same concept. All right. So we'll go ahead and finish the rest of them. There's 6, 7, 8, 9, 10, 11, 12. And that's it for your review. We're almost done with it. So maybe I'll try to limit it to 2 hours, depending how far we get, because those last problems are a bit more time consuming. Maybe we might do a section, maybe we might not, but we'll see what feels comfortable. So we'll meet on Thursday, just because I want to be available to you if you have any questions before your exam.
Okay.
Sounds good. All right. Well, thanks for sticking around. I know it went longer than I would have liked, but it's okay. I won't try to keep them longer than this. So have a nice day. This will be posted on YouTube, so you can check it out on your free time if you like, or whatever. Yeah. Do you have a
Miss
question, Sal?
Angelica,
Yeah.
Yeah. For chapter 5.2, are you gonna reopen that quiz again?
I think it's open. It
I tried it and it said it was locked.
was locked? Oh, okay.
Yeah.
I'll open it. I'll open it right now.
Okay, cool. Thank you.
Thank you for letting me know, Sal.
Yeah, no problem. Thanks again.
Thanks.
Bye.
Bye. I'll open all chapter 5 and 6 because this will be open. Same for your homework. Alrighty. Well, that's it for today. Have a nice evening, nice day.